Hi everyone, we are Team excITE. We are students from ITE College Central, and my group consists of Eugene, 𝙍𝙬, and Shijun. 𝙍𝙬 and I are currently studying electronics engineering, whereas Eugene is currently studying cyber and network security. This is our first time participating in RoboCop.
We are participating in the Rescue Region Challenge in the tertiary level. Our challenge is to achieve as many points by collecting as many color objects as possible and deposit them using the built-in camera from the robot by detecting the April tag within 6 minutes. In these 6 minutes, we also have to ensure that the robot does not enter the gray area and traps, as it will slow down the robot and disrupt our collection and deposition process. We also have to ensure that the robot stay within the boundary of the net to avoid getting a penalty, which the robot will be frozen for 10 seconds. The list of method and strategy we have used, such as using the compass when the robot is around the swampland area to orientate the robot to go toward the deposit area. Using the ultrasonic to avoid clashing towards the obstacle, using the camera to detect the orange depositing area so that the robot will go towards it, as well as using it to navigate the area by detecting the green color tag outside the boundary. Using the camera again to detect red April tag so that it will turn the robot to detect our April tag instead. In the software, we also use the print function to see the process of the robot is currently doing and debug if there is a need to. And lastly, improve the April tag detection by lowering black and white image threshold in the shadow.
Here's a more in-depth explanation of how we use the red team's April tags to find our tags and deposit. Firstly, we identified which April tag has not been stored in the library. To store the tag data, we recorded down the binary value of each row of the April tag and converted them into hexadecimal values using a calculator. We then stored them into the April tag detector library. Next, we made a new else-if condition in Game 1 so that when the robot sees the red team's April tag, whatever's in the condition will run. In this case, it is duration equals 0 and cure action equals 11. In case 11, we have a if-else condition where if the robot is facing a direction within the compass's range, it will turn left or right so that the robot will be going towards the blue team's April tag. To make sure that the deposit happens, we made a new case to adjust the robot's direction and speed when the camera sees that the April tag is moving out of its field of view. The strategies used have proven to be effective as our average score is 2064 and our highest was 2550. However, we think that we can do better and we aim to get at least 2000 for every game. The detection of the color tags around the map have not proven effective yet due to the shadows. Additionally, the robot is still not able to detect the super object very well, causing us to lose out on points. When the game starts, the robot will immediately start looking for the color objects. Once collected, it will go to the deposit area. Since it has deposited a full set of red, black, and cyan, a super object is created. The robot has once again collected a full set of the color objects, creating a super object. We made use of the map's boundary to bounce our robot off and go to the deposit area. The robot collects 2 of each colored object, hence creating a super plus object. Throughout the game, you'll realize that each colored object has its own respective points. Red has 10, cyan has 15, and black has 20. When the colored objects are in the blue area, the points are doubled. Why are the points different? It's not the same as the previous one where we got 180 points, as it was created with only one set of colored objects. We've just collected another super gem which gives us another 90 points. Over here, we use the robot's compass to make it turn towards the deposit area after bouncing off the trap.
Applying knowledge gained to the real world. We can apply the knowledge gained to deploy a robot in the agricultural industry. It can help to reduce the extra usage of water and fertilizer, as well as monitor and manage crops more efficiently. For example, we can use the color sensor to analyze color variation in leaves and fruits. Using camera to detect the April tag to provide requires special attention for the plants.
As for using AI tools, we mainly use ChatGPT to help us explain what the demo code does in the April tag detector and the color patch detector library, as we couldn't understand the variable and the function used.